In this issue of Ningdian Interview, Jian Jigang will further analyze the security risks of the software supply chain and the measures we can take to strengthen its security. Software production also depends on external materials like open-source software. Risks associated with open-source software have become a key focus in recent years. For instance, in 2021, the Apache Log4j2 open-source project was found to have serious vulnerabilities, allowing attackers to remotely execute code and control target machines. This affected numerous users globally, including major commercial applications. Licensing issues with open-source software also pose risks, as improper handling can lead to business or legal disputes. In software development, personnel quality and skills significantly affect software quality. Incompetent or careless developers may produce low-quality or buggy software. Thus, software supply chain security must also address personnel training and management. In the transmission link, software passes through multiple nodes from producer to user, each potentially posing security risks. For instance, the SolarWinds supply chain attack exploited vulnerabilities in SolarWinds network management software, affecting U.S. federal agencies and Fortune 500 companies. This attack was widespread, concealed, and complex, with a long latency period. It highlights the need for rigorous checks and testing during software transmission to ensure it remains untampered and free of malicious code. The final phase is usage. Even if software is secure during production and transmission, risks may emerge during use. For example, a Guangxi education sector expert shared a case. During attack defense drills, attackers retrieved system source code from GitHub, conducted audits to identify vulnerabilities, and exploited them. Additionally, open-source components can expose serious vulnerabilities during use, requiring timely remediation. Thus, users must establish an effective vulnerability response mechanism to ensure swift identification and repair of discovered vulnerabilities. From a broader perspective, software supply chain security also affects national and industrial security. If external forces control or disrupt the software supply chain, the entire industry chain could face interruptions or paralysis. For instance, during the Russia-Ukraine war, the US restricted Russia's access to certain open-source information and software. Additionally, software containing malicious code or backdoors could pose significant national security threats. Strengthening protection and supervision of the software supply chain is therefore essential. To address these risks, several measures can enhance software supply chain security. First, establish an effective security assessment and detection system to comprehensively evaluate software safety. Second, strengthen personnel training and management to improve developers' security awareness and skills. Promoting industry education integration and school enterprise cooperation is also vital to cultivating more software security professionals. Finally, enhance international cooperation and exchanges to tackle software supply chain security challenges collaboratively. SecZone contributed to releasing national and local standards and actively promote industry education integration and school enterprise cooperation. Additionally, SecZone developed platform tools to enhance software supply chain security protection and detection. These achievements have been applied and promoted across various cities and industries. Due to issues in the software supply chain, three main problems need to be addressed. First, autonomy, meaning domestically produced and controllable software. Second, the maturity of the software industry chain. And third, the development capabilities for security. From these three levels. First, regarding autonomy, China has achieved independent capabilities in areas like CPUs, operating systems, and databases, with a gradually forming ecosystem for basic software localization. However, at the application software level, particularly for common software, more than 90% or even 95% of open-source software comes from foreign platforms. Industrial software, too, lacks sufficient autonomy. To improve this, the Ministry of Industry and Information Technology is issuing policies encouraging domestic universities and enterprises to co-develop industrial software and promoting the growth of the domestic open-source industry. Secondly, regarding maturity, software engineering is still less mature compared to industries like construction, food, and even traditional automobile manufacturing. To improve maturity, more standards need to be developed, and related work must be further standardized. This will not only increase autonomy but also enhance the resilience of the software industry and supply chain. At the national level, efforts are being made to improve the comprehensive network security system, covering software suppliers, buyers, and third-party testing institutions. Finally, regarding security development capabilities, these are essential for supporting digital capabilities. Cities, local governments, large central enterprises, state-owned enterprises, and listed companies are all improving their digital capabilities. Software supply chain security, as a key component of digital capabilities, is receiving increasing attention. These organizations not only need traditional network security capabilities but also the ability to secure the software supply chain. Traditional software developers will face stricter software security requirements, which will drive them to improve their security development capabilities, either proactively or reactively. In general, from macro to micro, China's software supply chain security system will gradually improve, laying the foundation for the high-quality development of the software industry.